Have you ever looked up at the night sky and wondered how the stars got up there? Or have you ever looked at bugs in a microscope and wondered how something so small can be alive? Well, if you're curious about really big things and really tiny things, maybe you should be a scientist. But not just any scientist, a physicist. Physics is the science that studies matter, how it moves, and what it does. It also studies related things like energy and force. Physics is a very important science because it helps us understand how the universe works. It includes studying things that are very small, like particles, all the way to things that are very big, like galaxies. For example, there's a tiny world called the quantum world. In this world, things are very different from the world we live in. In the quantum world, things can be in two places at once. That's called being in two states at the same time. In our world, we have things called atoms. Atoms are like the building blocks of everything around us. In the quantum world, atoms can be in two states at the same time too. This is called superposition. We also have something called quantum entanglement. This means that if two atoms are connected in a special way, they can change what they are doing at the same time, even if they are very far away from each other. It's like if you and your best friend had special bracelets, and if you move your hand, your best friend's hand would move too, even if you were on opposite sides of the world. Now, the thing about the quantum world is that it's very hard to see. We use special tools and experiments to help us understand what's happening. But what we do know is that the quantum world is very important for things like computers and cell phones to work. Without the quantum world, our technology wouldn't be as advanced as it is today. So, even though the quantum world is very different from the world we live in, it's still a very important part of our lives. And to learn more about it, we need amazing scientists who want to study quantum mechanics. Quantum mechanics is a highly successful and accurate theory that has greatly advanced our understanding of the natural world. It relies heavily on mathematical models, which can be difficult for the average person to understand and interpret. This lack of public understanding and trust in the field can limit its potential applications. Some of the predictions of quantum mechanics, such as superposition and entanglement, are counterintuitive and difficult to reconcile with our everyday experiences. Superposition and entanglement are two fundamental concepts of quantum mechanics. Superposition is the idea that a particle can exist in multiple states simultaneously, while entanglement is the phenomenon where particles remain connected to each other regardless of their distance apart. These concepts help explain phenomena such as wave-particle duality and the observer effect, which are two of the most important principles in quantum mechanics. Superposition and entanglement are essential concepts that help lay a foundation for understanding the behavior of particles on an atomic level. They form the basis for many technologies such as quantum computing, cryptography, and teleportation. By exploring these concepts further, we may eventually unlock even more secrets about our universe. But as you can imagine, these concepts are difficult to fully understand, which of course makes people doubt the science behind it. Additionally, quantum mechanics is not able to fully explain certain phenomena such as the nature of consciousness, leaving some important questions unanswered. Certain predictions of quantum mechanics, such as the observer effect, seem to suggest that the act of observation can change the outcome of an experiment. This raises questions about scientific measurements and their objectivity. Furthermore, quantum mechanics is not a complete theory and must be combined with general relativity, which explains gravity, to make sense of the universe on a larger scale. These two theories have yet to be successfully unified, making it difficult to make sense of the whole universe. Some of the implications of quantum mechanics, such as the potential for quantum computing, have yet to be fully realized and may prove to be more difficult to implement than initially thought. Despite these limitations, quantum mechanics has been accepted by the scientific community as being highly successful and accurate. Its applications have been far-reaching, and it has greatly advanced our understanding of the natural world. As such, further research into quantum mechanics is necessary in order to push its boundaries and uncover more of its potential. With continued study and exploration, we may one day be able to fully understand the implications of this remarkable theory. However, this understanding will require a great amount of work and dedication. It is up to the scientific community to continue pushing the boundaries of quantum mechanics and discover more about this fascinating theory. Its potentials are yet to be fully realized and explored, but its impact on our understanding of the universe has already been immense. With further research and exploration, we may one day be able to gain a more comprehensive understanding of this remarkable theory and its implications for the whole universe. One of the biggest critics of quantum mechanics is Albert Einstein. He was famously quoted as saying, "God does not play dice with the universe." This critique was based on his conviction that a deterministic universe was more reasonable than one governed by chance. He felt that the probabilistic nature of quantum physics lacked predictive power and could only be used to calculate the probability of an event happening, rather than actually predicting it. This critique is still valid today as many physicists and philosophers struggle to make sense of how quantum mechanics can be reconciled with our everyday understanding of cause and effect. Nevertheless, many experiments have confirmed the predictions made by quantum physics, demonstrating that it is at least a useful tool for scientists to use in their understanding of the universe. Building upon Einstein's critique, David Hume and Immanuel Kant proposed that a hypothetical world without causality contradicts our inherent understanding of the universe. This debate is ongoing today and continues to captivate physicists as well as philosophers with its profound implications. Einstein's critiques of quantum mechanics, along with those of Hume and Kant, are valid in that they challenge us to consider more deeply what it means for the universe to be governed by chance rather than a deterministic cause and effect. They provide important insights into how we can better understand our world, even if their criticisms have not been fully accepted by the scientific community. Deterministic cause and effect means that for a given set of circumstances, the outcome is predetermined. That is to say, if one can fully describe an initial state, then it should be possible to exactly predict the future behavior of the system. This contrasts with probabilistic cause and effect, which allows for different outcomes depending on random factors such as chance or luck. In a deterministic universe, every event is caused by a previous one and its future behavior can be known ahead of time. A real-world example of deterministic cause and effect is a ball rolling down a hill. Assuming the hill is perfectly smooth and there are no external forces acting on it, then we can accurately predict how the ball will move based on its initial position and speed. If we know where the ball starts from, how fast it is going, and the shape of the hill, then we can accurately calculate where it will end up. This is an example of a deterministic cause and effect system, as the future behavior of the ball has been entirely determined by its initial state. In contrast, a probabilistic cause and effect system would allow for some randomness in the result, as the outcome could be affected by random factors such as wind or other external forces. In this case, predicting the future behavior of the ball would become much more complicated. Now let's talk about some of the critiques of quantum mechanics and which theories are best accepted to validate quantum mechanics. Even though Albert Einstein criticized quantum mechanics, his theory of relativity helps somewhat validate the field of quantum mechanics. His theory helps us understand how things move and how time works. You know how sometimes things look different depending on where you're standing or how fast you're moving? That's what the theory of relativity is all about. It helps us understand how things look different to different people, depending on how fast they're moving or where they're standing. One of the most important parts of the theory of relativity is something called time dilation. This means that time can seem to move faster or slower depending on how fast you're moving. It's like if you were on a super fast train, time would seem to go slower for you, compared to someone who was standing still. Another important part of the theory of relativity is something called length contraction. This means that things can look shorter or longer depending on how fast you're moving. It's like if you were on a super fast train and you looked at a broomstick, it would look shorter than it does when you're standing still. The theory of relativity is also important for things like GPS. GPS is what helps us find our way when we're driving or walking. Without the theory of relativity, GPS wouldn't be as accurate as it is today. So, even though the theory of relativity can be hard to understand, it's a very important part of how we understand the world around us. But it's only a theory, and some theories aren't black and white. A theory is like a big puzzle. Imagine you have a big box of puzzle pieces, and you want to put them together to make a picture. A theory is like a picture that scientists want to make using all the pieces of information they have gathered. A theory is an explanation of how things work in the world around us. It's like a story that scientists make to explain why things happen the way they do. For example, scientists have a theory about how the Earth goes around the sun and how the seasons change. They use information from experiments and observations to put the puzzle pieces together and make the story. Scientists use theories to make predictions about what might happen in the future. Like if you know how a puzzle should look like, you can use that information to predict what other pieces might fit in a certain spot. Scientists use theories to make predictions about things like the weather, or how a new medicine might work. Theories are not just guesses or opinions. They are based on a lot of facts and evidence. Just like a puzzle, scientists have to make sure that all the pieces fit together and make sense. They have to test their theories to make sure they are correct. Sometimes, new information comes along and scientists have to change their theories. They might find a piece of the puzzle that doesn't fit, so they have to make a new picture. This is how science works. Scientists are always updating their theories as they learn more about the world. Again, a theory is based on facts and evidence, and it helps scientists make predictions about the future. Theories are not just guesses, they are based on scientific evidence and are subject to change as new information is discovered. What isn't a theory is how cosmologists play a big role in understanding some of life's biggest questions. They wanted to know how the universe started, how it's been evolving, and how it will end. This is the field of study called cosmology. You know how when you look up at the night sky, you see stars and planets? Well, cosmologists study everything that is out there, including galaxies, stars, and planets, but also things we can't see like dark matter and dark energy. One of the most important ideas in cosmology is that our universe started with a big explosion a very long time ago, called the Big Bang. This explosion created all the matter and energy that makes up everything we see today. Cosmologists use special telescopes and satellites to study the light left over from the Big Bang to learn more about how the universe began. Another important concept in cosmology is the expansion of the universe. Just like how a balloon gets bigger when you blow air into it, cosmologists believe that our universe is getting bigger and bigger. But it's not just getting bigger, it's also getting colder. Imagine if the balloon was getting bigger and the air inside it was getting colder. That's what is happening with the universe. Cosmology is also important for understanding the fate of our universe. Will it continue to expand forever, or will it eventually stop and collapse? Scientists have different theories about the fate of the universe, but cosmologists continue to study and gather data to try and answer these big questions. So, even though the study of cosmology can be hard to understand, it's a very important part of how we understand the world around us. The universe is a big place, and cosmology helps us to understand it better. Like cosmologists, physicists are also intrigued by galaxies far, far away. Physicists use things like math, experiments, and special tools to help them understand how things work in the world around us. Physics is all around us. It helps us understand things like how a ball bounces, how a car moves, and even how the wind blows. Physicists study things like energy, matter, and motion. They try to understand the laws that govern the natural world, like gravity and electricity. To study physics, Physicists do experiments. They might drop a ball from a tall building to see how it falls, or they might use a big machine called a particle accelerator to smash tiny particles together. They use these experiments to learn new things and test their ideas. Physicists also use math to help them understand how things work. They write equations that describe the behavior of the natural world. It's like a secret code that only they can read, but it helps them to understand how things work. Physics is a big field with many different areas of study. For example, some physicists study the very small like subatomic particles, others study the very large like galaxies and the universe. Physicists can work in a laboratory, in a university, or in a company. Their work helps us understand how things work in the world around us, from the tiniest subatomic particles to the largest galaxies in the universe. So, when it comes to understanding the world around us, cosmology and physics play a big role. By studying the universe, we can learn more about our past and our future, and by studying things like energy and matter, we can make sense of how things work in the world today. Together, they are helping us to unlock the mysteries of the universe. Cosmologists and physicists have been studying these things for hundreds of years, and their research continues to bring us new discoveries all the time. Every new discovery helps us to understand our world a little bit better, and that is why cosmology and physics are so important. Without them, we would not be able to understand the world around us.